This naturalrefrigerants.com article is being read by an automated voice. Hanon Systems Estimates, TFA Levels, generated by Automotive F-gas emissions. By Michael Gary, published June 2nd, 2026. Hanon Systems, a major South Korean provider of automotive thermal management systems, has released a report estimating the amount of trifluoroacetic acid, TFA, generated in Europe by emissions of refrigerants HFC 134A and HFO 1234YF from car cooling and heating systems. The report also describes the opportunity to limit TFA creation via the use of CO2 and propane as alternative refrigerants. Hanon calculated a cumulative TFA load of approximately 68,000 metric tons through 2025 in Europe. Using 3 separate regulatory scenarios, the company projected a cumulative TFA load from 2028 through 2058 of 240,000 metric tons, no regulations, 143,000 metric tons, regulations with exemptions, and 102,000 metric tons, regulations without exemptions. The report lied TFA contaminations caused by fluorinated gases inside mobile air conditioning systems and already available alternatives was authored by 2 Hanon executives, Dr. Roman Hecht, Global Chief Engineer for Natural Refrigerant Systems, and Dr. Henning Freitag, Natural Refrigerant Systems Development Engineer. The report can be downloaded via Hanon's announcement on LinkedIn. Hanon manufactures components for CO2 and R290. Air conditioning and heat pump systems. Atmosphere, publisher of naturalrefrigerants.com, will be hosting a webinar to discuss the report on June 18th at 3 p.m. Central European Time. The report outlines a model devised by Hanon to calculate and evaluate TFA created in the atmosphere from refrigerant leakages in passenger car cooling and heating systems, assuming an average refrigerant charge per vehicle of 500 grams. The model focuses on passenger cars in Europe, including the EU27, the European Free Trade Association, EFTA countries, and the United Kingdom. It covers internal combustion engine vehicles, ICE, hybrid electric vehicles, HEV, plug-in hybrid electric vehicles, PHEV, and battery electric vehicles, BEV. For systems with electric compressors, the model used an annual leakage rate of 3% of the nominal refrigerant charge. For systems with mechanical compressors, the model uses 5% per year. In addition, it includes a further 2% leakage due to crash events, where the release of the full charge is assumed. The main goal is to quantify current and future emissions, and to show the impact of different future regulatory scenarios, said the report. The EU's European Chemical Agency, ECHA, is currently considering a sweeping restriction of PFAS that would include certain F-gas refrigerants and TFA, with a possible enactment of regulations in 2028. Annual TFA emissions are rising strongly, the report noted. This will continue for the next 10 years at least, unless a PFAS restriction leads to an early switch to natural refrigerants. Moreover, the report said, thermal management systems using CO2 are already established in battery electric vehicles, and designs using R290 are under active development and validation. This shows that compliance with stricter PFAS regulation is technically achievable and, more importantly, already available for the mass market. TFA, an ultra-short-chain example of PFAS, per- and polyfluoroalkyl substances, is formed in the atmosphere by the breakdown of certain F-gases, notably HFC 134A, a 7 to 20% decomposition over approximately 14 years, and HFO 1234YF, a 100% decomposition over 12 days. Over the past 30 years, HFC 134A and HFO 1234YF have been introduced as refrigerants in car air conditioning systems, with the former now being phased down as a high GWP greenhouse gas. TFA formed in the atmosphere is delivered to Earth in rainfall, and it is also created by the breakdown of pesticides and pharmaceuticals and from other sources. Consequently, it has proliferated in the global environment, accumulating as a forever chemical in surface water and entering drinking water, beverages, foods, and ultimately human blood serum, though it has a short half-life in the body, about 32 days. Its effect on human health is being investigated, with a 2025 study at the University of Milan pointing to an impact on the immune system. Germany has recommended to the EU that TFA be classified as reproductively toxic, but the chemical industry asserts TFA is not harmful, citing reports from the UN Environment Program, UNEP. Historical TFA creation. In its report, Hanon calculated that the use of HFC 134A, starting in the mid-1990s in air-conditioned vehicles, led to the creation of roughly 2,000 metric tons per year of TFA by 2010. But after 2014, a steady transition to HFO 1234YF took place as a result of the EU MAC directive, which fully banned HFC 134A as of 2017. By 2025, annual TFA emissions exceed 6,000 metric tons per year, with R1234YF accounting for more than 80% of the total emissions, but only 44% of the vehicle fleet, the report said. Integrating the annual values of the F-gas refrigerants, the report calculated a cumulative TFA load of approximately 68,000 metric tons through 2025. Of this, about half derived from historical R134A use, while the other half has accumulated during the brief but rapidly expanding era of R1234YF, it said. In projecting the amount of TFA that will be generated by emissions of refrigerants used in car AC and heat pumps avert during a 30-year evaluation period ending in 2058, the report's model developed three scenarios. Under the first baseline scenario, there are no PFAS-related EU restriction for passenger car refrigerants. Thus, the historical shift from R134A to R1234YF continues, but there is no additional regulatory push away from R1234YF. In the baseline scenario, emissions rise until 2036 and exceed 9,000 metric tons per year. At that time, the full EU car fleet is transferred to R1234YF, except for a smaller number of cars built by the Volkswagen Group that continue to use R744, the report said. After the peak in 2036, TFA emissions decrease slightly because of fewer leakages due to increasing number of electric compressors replacing mechanical compressors and the corresponding lower leakage rate. Moreover, the overall car fleet volume is assumed to decrease. Over the 30-year baseline evaluation period, cumulative TFA emissions reached 240,000 metric tons, the report said. This would be 3.6 times more than the cumulative TFA load caused by the EU passenger car fleet over the previous 50 years. The report also considered a second scenario model, Restriction Option 1, RO1, described in the ECHA PFAS Medohash restriction proposal documents. It assumes a full PFAS ban after an 18-month transitional period. Only the service of existing vehicles would continue with R1234YF after the ban date. Annual TFA emissions do not rise above 9,000 metric tons per year because the restriction becomes active before the full vehicle fleet has transitioned to R1234YF, the report said. However, even this strict restriction option would still result in an accumulated TFA load of 102,000 metric tons during the evaluation period, which is 1.5 times more than the cumulative TFA load caused by the EU passenger car fleet over the previous 50 years. The third scenario is Restriction Option 2, ER02, for which the PFAS ban has derogation exemption periods of 5 years for BEV passenger cars, and a derogation period of 12 years applied to all other passenger cars. Because of the derogations granted under RO2, annual TFA emissions continue to rise until 2036, even though entry into force of the regulations occurs in 2028. The TFA peak is nearly as high as in the baseline scenario without regulation. Cumulative TFA emissions over the relevant 30-year period reach 143,000 metric tons, which is 2.1 times higher than during the previous 50 years. A key finding in the report is the need to convert as many vehicles as possible to alternative refrigerants before the entire fleet is converted to R1234YF by 2036. Only in this way can the enormous TFA emissions peak of more than 9,000 metric tons per year truly be avoided. The report noted that its model is not a full life cycle model and does not include aspects such as production of refrigerants, leakages during vehicle manufacturing, detailed servicing procedures, end-of-life refrigerant recovery, or detailed representation of atmospheric processes. Also, the rapidly increasing electrification of the EU vehicle fleet will cause a growing share of vehicles to be equipped with heat pumps, which often require considerably higher refrigerant charges. This means that the expected annual TFA peak may in reality be significantly higher than 9,000 metric tons per year. It should therefore be clearly stated that the present model carries a risk of underestimating future TFA emissions. CO2 is ready. The report stressed that passenger car thermal management systems based on PFAS-free CO2 refrigerant are ready for widespread application across the mobile air conditioning market, except for pure ICE vehicles. This also includes all hybrid vehicles using an electric refrigerant compressor. In 2020, Volkswagen introduced a thermal management system using CO2 on its first all-electric vehicle platform, the Modular Electrification Toolkit, MEB. The system also integrated a heat pump, well suited to battery electric vehicles that lack waste heat from a combustion engine. In winter conditions, the heat pump significantly improves heating efficiency, helping to reduce vehicle range losses, said the report. There are now more than 1 million VW MEB cars using CO2 refrigerant on the road in Europe, the report said, adding that about 10 to 15% of newly registered battery electric vehicles are equipped with CO2 thermal management systems. Hanon is also developing and optimizing systems and components using R290 as a refrigerant. Due to its flammability, R290 was not initially considered during the early development phase of natural refrigerant systems for Mac applications. As a result, this solution is at an earlier stage of development compared to CO2. Hanon has found R290 suitable for thermal management of battery electric vehicles, including battery conditioning. A potential start of production with key R290 components is planned for 2029. The extent to which R290 is suitable for use in vehicles with hybrid drive systems would still need to be investigated, the report said. According to Benedikt Schauter, thermal management development lead at German automotive supplier ZF, automakers are showing high interest in R290-based thermal management systems for electric vehicles.